Welcome to this Ice Warm webinar. It's great to see so many on board and from 10 countries. I'm delighted today to welcome 7 water professionals from Rajasthan, and they're going to present on their current work and study here in Australia. Their visit is generously funded by the Australia-India Council, Department of Foreign Affairs and Trade, Ice Warm, and the South Australian Department of State Development. The group are being hosted by DEWNR, Department of Water and Natural Resources, SA Water, Flinders University, and UniSA. My name's Trevor Pillar. I'm the National Partnerships Manager here at Ice Warm. The screen you see now is the webinars that we have coming up in the future. These are all free webinars, and I won't go into them all in detail right now, but as we get into 2018, there's a large number of webinars on our planning. For today, let's get this going. The format is 3 minutes per presenter, and there's 7 presenters, and then after they've presented, we have 25 minutes open to you. Well, I would like to now hand over to the first of our speakers, but as I do this, a couple of things. One, they were yesterday receiving their certificates for their time here studying in South Australia. There's the Minister, Hamilton Smith, presenting each of the water professionals with their certificates, and also the Managing Director of Ice Warm, Daryl Day. It was a great day and much celebration. I would like now to introduce Dr. Dinesh. Before I do that, all of these 7 professionals from India come from the Water Resources Department, Public Health Engineering Department, and universities around Rajasthan. And we're so delighted they could be with us here for this 6-7 weeks in their study tour. And right now, I'm going to hand right over to you, Dr. Dinesh, Public Health Engineering Department, Rajasthan, India. Thank you very much for your time.
Hello, everybody. Myself, Dr. Dinesh Kumar Periwal. Good morning to my countrymen in India, and good afternoon in here, South Australia and Australia. I have come here for 6 weeks in South Australia. I have worked with SA Water on the subject evolution of energy efficient techniques for sustainable water use, development of smart grid for drinking water supply management. Here we have compared the water supply of Jodhpur city and this Adelaide city, Metro Adelaide, Greater Adelaide. We are having very similarities in our city in Rajasthan cities and at South Australia cities. The Jodhpur city is having a population of 1.5, and the South Australia, this Greater Adelaide is having city about population of 1.3 million. We are having surface sources at Jodhpur. Many number of sources are there for this Greater Adelaide. Service level at Jodhpur is about 125 LPCD, and here we are having about 300 LPCD. At Adelaide, we are having 24/7 water supply. We are just struggling for 2 to 3 hours supply on alternate day. The water tariff rates are also very cheap in our state. Here, they are charging very good rates for the water supplies, but they are having very good pressure supply. About 30-meter pressure supply is there at every household location. The design water demand is also more than 300. They are having all type of data for even up to consumer end. They are managing the all water supply with this telemetry system, automatic SCADA system. All things are linked with the river basin. All linkages are there for river basin water levels, raw water pumping stations, water treatment plants, reservoirs, pumping stations, and all peripheral pumping stations up to the head office at SA Water. Every report in regard to any water consumption readings, the water billing, consumption pattern, any interruptions in water supply, system calendar, all are available on the system here. Therefore, the water supply of Adelaide is very good and very distinctly managed. A very good management system is there. Compared to when we see here the Adelaide water supply management system, many just very recent softwares are there, and every software is being used very efficiently in the respective fields. The GIS platform for data collection, inspection, and asset management is very decent. SA Water maintains a metropolitan regional telemetry system for surveillance and monitoring of 24 hours for the performance. All these systems can be introduced in our state also, and that can help in a greater way. Thank you.
Thank you very much, Dinesh. That was excellent. It was a lot of material to get through in a hurry. Now, the most interesting topic now from Bhavana Kanwar, Malavia National Institute of Technology in Jaipur, Rajasthan. Right over to you, Bhavana.
Hello everyone, my name is Bhavna Kanwar and I am pursuing my post-graduation from MNIT Jaipur, Rajasthan. My topic is defluoridation of drinking water using adsorption process. So drinking water is primary need of everybody, and one of the source of drinking water is groundwater, and groundwater contains natural constituents like fluoride, arsenic, nitrate and salinity. WHO's guidelines permit around 1 to 1.5 milligram of liter in drinking water. Fluoride has its dual significance, like if we have less concentration of fluoride in our drinking water, we can get dental caries, and if we have excess of fluoride in our drinking water, then we can have fluorosis, and other organs of our body can be affected by that. So fluoride must be or should be excluded from our drinking water. So one of the process of removing fluoride from drinking water is adsorption. Adsorption is the property of a solid substance to attract and hold its surface. So I performed a jar test for removal of fluoride. So I had 5 coagulants, all natural coagulants. Those were alum, PAC, alkyl gold, cartesian and mics. The procedure of jar test was 1 minute flash mix at 200 rpm, and then flocculation for 14 minutes at 20 rpm, and settling for 15 minutes. After that, I found the results of all these 5 coagulants, and only alum was able to remove fluoride other than the all 5. So the reason might be behind of this would be the availability of free aluminum in alum was very higher compared to PAC, alkyl gold, cartesian and mics. So fluoride was more removed in alum other than the all coagulants. Thank you.
This is really interesting stuff, and sometimes the successes are good, sometimes failures give us lots of information. I want to just remind everybody to keep asking questions just before Jitendra started. There's a couple of questions on the board. Don't hesitate to begin to write your comments or discussion points. We'd be most happy with that. Right now, over to you, Jitendra, Executive Engineer in Water Resource Department, Rajasthan. Thank you.
Hello everyone, I am Jiten Dikshit, working as Executive Engineer in Water Resource Department, Rajasthan, Jaipur. And I have been placed with DEWNR, Department of Environment, Water and Natural Resources at Adelaide, South Australia, through ISWAM. My work area here is study of salient features of water policy of South Australia and recommendation for suitable adoption in Rajasthan state water policy. So in South Australia, water is planning and management is done through the Natural Resources Management Act 2004, that is NRM Act 2004. The water is managed broadly by 3 ways by legislation in South Australia. First, the management of activities that can affect water. For example, controls around the location and construction of wells and dams. And the second one, the control of the taking and use of water through a water licensing regime. Third one, the authorization or restriction of water use through a range of means available to the minister. First 2 parts are covered under NRM plans. Third one is out of NRM plan. That is solely depend on the rights given to the minister. And NRM plans are broadly 3 plans. One is state NRM plan, that is a aspirational plan having general goals. And second one is regional NRM plan. There are 8 NRM boards in South Australia, and each and every board is having their own NRM plan. And third plan is water allocation plan. Each NRM board is to have their own, they have to write their own NRM plan, water allocation plan. And water allocation plan is to be reviewed once in 10 years. DEWNR used to help them in writing the water allocation plan. A key purpose behind developing a water allocation plan is to manage a prescribed water resource via a system of property rights through the use of water licenses. A water license is required to take water in a prescribed water resource and gives the water user a right to access water from the prescribed resource. These water licenses can be tradable, can be transferred. So water trading enables licensees to manage their individual enterprises either by buying water to meet their water use requirements or selling or leasing water they are not going to use. A water license can be transferred either permanently or temporarily. DEWNR is not involved in setting prices for water. Prices are determined in the market by the value placed on water by buyers or sellers. Thank you.
That was great. Thank you very much, Jitendra. Now it's right over to Keshava, who's going to talk about non-revenue water. Keshava's from the Public Health Engineering Department. So over to you, Keshava.
Hi, my name is Keshav Srivastava. I am here in Adelaide as a research fellow in South SA Water, South Australia, sponsored by ICEWAR and Public Health Engineering Department, Jaipur. My topic is non-revenue water in Eyre Peninsula, SA Water. It's a standard water balance format given by the International Water Association. And we can find the answer to the such questions like where is water lost, how is water lost, and how much water is lost. And for these questions and their strategies and prioritizing the investments, it's very much essential. And in Eyre Peninsula, east side is Gulf of Spencer and west side is Great Australian Basin and north in Gaulier Range. And 15 DMAs are formed in this area. And distribution mains in this area is near about 3,139 kilometers. And number of connections in this area is 29,842 connections are there. And average static pressure in this area is nearly 42 meter to 102 pressure, which is much higher than the recommended by the IWA. And that's the problem. And to sort out this problem, it is essential that utilities provide water at high pressure, but service level everywhere all the time. And more water leaks due to high pressure. High pressure causes more waste, reduced pressure while providing quality service. And to control the high pressure, it is recommended that dynamic boundary valves should be used in this system. This is facilitated by replacing certain closed boundary valves. And for capacity building in this area, training yard can be constructed, which forms different type of materials of pipelines and using different type of acoustic instruments like AquaScan 820, Joniscan, AquaScan 610, hydrophone, packetophone, etc. And this is why should we reduce NRW? NRW, if we reduce NRW directly, our water savings will convert in the cost savings, and it will enhancement of sustainability of water supply service and improve the water supply management. Thank you. My special thanks to Mr. Ron Steele and Mr. John Borman.
That was excellent. Thank you very much. It's so critical an area, non-revenue water. Thank you for your questions. I can see them coming through. Don't hesitate to use the raise hand icon also. We'd love to see your face on screen. Right over to you now, Neelam, from Malavia National Institute of Technology in Jaipur, Rajasthan.
Thanks, Trevor. Hello, everyone. I'm Neelam Golcha. I'm doing my post-graduation in environmental engineering from Malavia National Institute of Technology, Jaipur, Rajasthan. At present, I'm interested in methods which are used for rapid and sensitive detection of E. coli in environmental waters. So we all know that water that we use for consumption today, for human consumption, is from the environmental sources. And contamination of these sources, water sources, is not very uncommon. There are a group of bacteria, which we call as coliforms, which will indicate the presence of contamination in environmental waters. So E. coli is one such specific coliform, which would indicate a fecal contamination of your environmental water. So what is the need of the hour today? We need rapid, highly specific and sensitive assays for detecting these bacterial indicators in your water samples for easy water monitoring, so that public health is not at risk. So during my fellowship here at SA Water, I had an opportunity to get introduced to a PCR assay, which is highly specific for detecting E. coli, which is a fecal indicator in environmental waters. So a PCR is like a polymerase chain reaction. So as the name suggests, it's a chain of events that's taking place. So we need a specific set of primers to begin this particular assay. So what do we need is, we need the genetic material of an organism, which we call as the DNA. I'm sure all of you are familiar with the term. So in a PCR assay, we are focusing, or we are going to amplify a specific portion of the DNA, and a number of copies of this target sequence is going to be produced. So in this experiment, which we conducted, it was the target sequence which we amplified was the YBBW gene from E. coli. In a recent study, it has been found out that this gene is exclusive to E. coli. So we have a specific set of primers, as you can see, and then we used to amplify this particular gene. A number of copies of this gene would be produced in case you have the E. coli contamination in your waters. So we need to do a DNA extraction from the water sample, and then conduct the assay where we have the primers which are ligating to your DNA sequences, amplifying it and producing like many copies of that particular gene segment. And the number of copies will be detected by the fluorescence that is being captured during amplification of your gene product. So as you can see, we have the fluorescence graph, the amplification curve in the top left corner. More the number of copies, we have higher number of we have the fluorescence is being increasing, and we can quantify the DNA by using a standard curve, where this will help in detect, like you can detect the number of, what is the amount of E. coli that's present in your sample. Thank you.
Well, you can see the scope of this is so wide. It's impressive, isn't it? I wanted to say one thing, though. That is that DEWNR have a group listening. Welcome to everyone there. It's such a good thing that you are supporting this work, and highly interested in the more than 1 billion people in this country, that in India, that these water professionals are so dedicated to seeing work. Anyway, I will stop there and it's right over to you, Niril, to talk about low-cost management of reverse osmosis. Thanks, Niril.
Hello, friends. I am Niril Kumar, working as Executive Engineer in Public Health Engineering Department, Government of Rajasthan. Here in SA Water, I worked on low-cost management of reverse osmosis plants, reject water. First of all, let me tell you the status of Rajasthan, the water scenario of Rajasthan. Rajasthan is the largest state of India. It's around 10.4% of the country's geographical area, 5.5% of human population, 18.7% of livestock, and we have only got 1.16% of the total surface water. 2/3 part of the state is the part of Great Thar Desert. Major source of drinking water is groundwater, and out of 33 districts in Rajasthan, 16 districts have poor quality of groundwater. The total population affected from quality is around 8 million in the state, out of which fluoride 4.3 million, salinity 2.9 million, and nitrate 0.8 million. So it's a huge problem. So for covering these quality affected habitation, the state has planned in two terms. First is long-term planning. So in long term, we are providing water to these habitations through surface sources, sustainable surface sources. And in short term, we are providing water to these habitations through community water purification plant. Most of them are based on reverse osmosis technology. The problem with reverse osmosis technology is the reject water, because around 60% water is purified water, and the rest 40% is released as reject water, which contains high contamination of fluoride, nitrate, and salinity. If you discharge this water directly in ground or in water bodies, it will create problems. Environmental problem, it may affect the groundwater and the soil. So I have discussed this issue here in SA Water with the people, because they have got very big plants working. So what they are doing with their plants, because most of these plants are ocean-based plants, so they are just putting that water into the ocean, the reject water. After discussion, we come to the conclusion that for low-cost management of this RO reject water, we have to opt 3 strategies, that is reduce, reuse, and recycle. Reduce means to increase the efficiency of these plants or to bring in some technology like captative deionization so that we can recover more amount of water and less reject water reduced. Reuse means reuse for other purposes, the reject water for say washing and then dishwashing and for agriculture purpose. But there is a limitation of this. And third is recycle. If it cannot be reduced or reused and the TDS of water is very high, then you have to evaporate it. Thank you.
Stunning, absolutely stunning figures, Niril, of Rajasthan's population and the water resources issues there. That helped give the big picture. Over to you, Pankaj, Executive Engineer, Water Resources Department, Rajasthan. Thank you.
Hello, everybody. My name is Pankaj Munjal, working as Executive Engineer in Water Resource Department, Rajasthan. Presently, I am placed with Surface Water Team in DEWNR. It's Department of Environment, Water and Natural Resources, Adelaide, South Australia, under fellowship program facilitated by IceBomb, South Australia. I have selected my work area, identification of trend or step change in rainfall pattern of Rajasthan by analysis of rainfall data at individual station level, basin-wise. In short, I want to discuss why to undertake an analysis of change. As being an executive engineer in the Water Resource Department, we all know water resources systems have been designed and operated based on the assumption of stationary hydrology. If this assumption is incorrect, then existing procedures for designing dams, reservoirs will have to be revised. Studies of change are also of importance because of our need to understand the impact that man is having on the natural world. A change may occur abruptly, it's called a step change, or gradually, it's called a trend. Changes can be seen in mean values or with in-year distribution. This is Rajasthan, which is one of the largest state in India. And this is the river basin map of the state, showing we have so many river basins, but we have only one perennial river, and all other rivers are rain-based rivers. We can see the western part of the state is the desert one, and all the river basins lies on the southern and eastern part. Our main water sources lies in the eastern part. We have seen a rainfall pattern is changing. The areas which were having a good rainfall are now having very less rainfall, and areas which were having very less rainfall are receiving a very high rainfall nowadays. This is a sample study of a Barmer district. We can see a trend analysis up to 1987-88. There was a reduction in the rainfall pattern, and after that there is sudden increase. The pattern is changing. For a pilot study, I have selected Banganga River Basin for my study area, and with the DEWNR team, I have a methodology of the work which I have fixed. Selection of one basin as a pilot projected, Banganga River Basin. Identification of rainfall stations comprising total daily rainfall data more than 45 years. Rainfall data, we have selected 13 stations of data is available, having more than 45 years data we have selected. Therefore, following 45 stations we have selected. Checking out the, in the next step, checking out the data consistency. Other one is the identification of trend, step change in rainfall pattern. And last, significance of trend by Mann-Kenders test. Analysis work of Banganga Basin is under progress and will be completed within 3 to 4 days. And based on the results of the analysis of Banganga Basin, I will further carry out the same analysis of rainfall data for all basins of the Rajasthan state. Outcome of the study will enable to identify the year of step change in rainfall pattern. With the help of this, my study I will further recommend the use of rainfall data rationally to assess the water availability in river basin. Thank you. Thank you very much.
Well, that is the completion of the presentations, and everybody stuck very closely to their script. And thank you very much. I just wanted to say a couple of things. A big thanks to SA Water, Department of State Development, and also DEWNR for their massive. And there we have a picture. That is outstanding. Thank you for joining us, everyone. we can now see some of the attendees at the webinar over there at UNA. Thanks very much for that, Joel. That's really good. But I wanted to say the sister state agreement between South Australia and Rajasthan, which Minister Hamilton Smith has been working with, and Carleen Maywood and lots of people. I shouldn't start naming names, I suppose. I'll get them thrown out. But there's been a lot of effort, and this is some of the results. But this is one of the big results of the sister state agreement. But I wanted to make a special thank you to SA Water, Department of State Development, and UNA. Well, now we have time. We have to save up a birthday greeting to Dr. Dinesh, so get your voices revved up. Dr. Dinesh turned 35 today. No, Dr. Dinesh, I think it's more than 35. You look 35. That's what I should say. You look 35. we sang him happy birthday earlier. I won't press on any further because we have a board full of questions. I think I'll start off with a person in India from the National Institute of Technology, Malavia National Institute of Technology, and Sunil has asked, what are the technologies in practice to manage reverse osmosis reject water other than solar evaporation, turbo mist evaporation, and deep well injection?
Actually, there is no particular technology available for RO reject management. Here in South Australia, they have got ocean-based reverse osmosis plant. So what they are doing, they are taking the raw water from the ocean and they are putting the reject water into the ocean back. So the main thing is that you have to use, reduce, reuse, and recycle. The combination of these three, according to the situation, you have to see that which thing will work for which plant. So that is the solution. There is no ready-made kind of solution that this particular solution is there and you have to implant that solution for this.
Now, thanks very much, Niril. Now, in fact, Sunil in Jaipur is coming on the screen to ask a question, or else we'll ask it live himself. So over to you, Sunil.
Hello.
There we go. Hello. I can hear you, Sunil.
Hello.
Welcome,
hello, sir.
From Jaipur. Welcome.
Yes, sir. Yes, sir. Your presentation were very good, sir.
Good.
And I have a question to Bhavna Kaur.
Yes. Ask your question.
Only the alum is removing the fluoride, but what about the others, PSC and others? Is it because of the pH?
Hello, sir. Good morning. The reason behind alum is working is, I already told in presentation that only in alum free aluminium is present. In alkyl gold, it is a polymeric structure, so there is a very less availability of free aluminium. That is why only alum is giving results, not the other ones.
Yep. No, thank you very much for that. All right, let's go on to the next question from Ramu in Queensland Health in Ipswich. Ramu has said, for defluoridation, have you tried Nalgonda technique?
We are trying Nalgonda practice in most of the portion of Rajasthan. In Nalgonda, we lime with alum. Lime helps in the maintaining of pH of water, and alums help in removal of fluoride. Lime maintains the pH so that the pH of water does not go far into the acidic portion, which helps in more residual of aluminium ion. So in Nalgonda practice, we are adding lime and alum.
Yep. That sounds good. The other question from Botswana was, what are the best innovation in E. coli detection?
Could you repeat the question?
What are the best innovations in E. coli detection?
Okay, this the one that I presented today is, to the best of my knowledge, that's the best, because we don't have a study which tells that the YBBW, we don't have there is a gene, there's any other gene which is highly specific to E. coli.
Right.
So to the best of my knowledge, this is the best to date.
Yep, that sounds good. The other question, what's the percentage of organic contents in drinking water? What's the percentage of organic contents in drinking water?
No, it's
a bit of a broad question.
Is it related to the E. coli part?
I don't know. No, I don't know. No.
No, we don't have, it's like 0% of organic matter in drinking water.
in Rajasthan.
They are allowed.
They have natural organic matter in South Australia.
Oh, all right.
In
But in
Punjab.
Rajasthan, we do not have the problem of organic matter in drinking water.
Gotcha. Okay. Yep. No, thanks for that. And the other question along that line is, please discuss what you've observed in South Australia that could be applied in Rajasthan, given the differences in water revenue generated. That's a pretty big, wide question. If somebody has a thought straight off the cuff for that, that'd be really good.
For water revenue generation, smart meters can be used.
Smart
Here
meters,
in
yeah.
Adelaide, they are using smart meters, and it's very simple to use them. And it can be placed over the mechanical meters. And by forming the DMA in Central Business District of Adelaide, they are doing this with 100 meters, and away from the Adelaide 1000 kilometers, they are doing with 1500 connections. And they are getting efficiency of the DMA through the these smart network, smart meters, and the data comes in the morning, and they analyze it on which part the revenue is leaking. They analyze and they collect the things.
Okay. Chatra Ram has asked, what is the best method of ROC treatment for small capacity reverse osmosis? The best method for ROC treatment for small capacity RO.
ROC treatment.
Reverse osmosis concentrate.
So that must be the reject water from.
Okay. What is the best method?
Yeah.
Actually, I have previously told that you have to see that the plant which is generating reject, what is the TDS of that reject?
You definitely did. Yep.
If the TDS of that reject is below 3000, the generation of TDS, then you can use that water for cleaning, for washing, for growing some kind of plant. If it's more than 3000, then most of the water that is useless, and yet you have to evaporate it. That is the only solution.
Yep. No, that sounds great. That's great. We've got a few more questions here. Is there a smart IT system for water treatment? This is from the person from Botswana. Is there a smart IT system for water treatment?
Yeah, there are smart residual chlorine identification techniques are there used in the Adelaide.
Yep. So
sensors are placed in the CBD, and they give the readings every morning.
Yep.
Chlorine testing, residual chlorine testing.
Every process, they are having smart metering and process control.
Process control, yeah. Mm.
And in laboratory also, a state-of-art laboratory in the Adelaide. It has all the things on the IT platform. IoT techniques are used in the laboratory also.
Yep. We've got a couple more questions, and I'm looking at them now. This one is not absolutely clear to me, but for trend analysis, MK test is being used.
Yes.
Trend analysis, MK test being used. So you understand that. What about modified MK test? Have you tried a modified MK test? And could you tell us further about the method selected for step change detection for that study?
At present, I have just used the...
Come a little bit closer to the microphone. Just come in a little bit closer to the mic. That's it. Yeah. Good.
I have only used a Mann-Kendall test. I have not used a modified Mann-Kendall test, so I cannot comment.
Okay. Yep, no, that's fine.
My analysis is under process, so it may be possible we may use the modified Mann-Kendall test if the DEWNR suggest me.
Yep, that sounds fantastic. Basant Mahu, I can't say the surname. We'll leave that. Don't laugh. Basant is in the University of Sydney in New South Wales. He's just returned from IGWC 2017 in Delhi. Just come back from that conference. There was a paper presented about uranium traces in water. Has anyone an opinion on uranium traces in water?
Yeah, uranium is there in water in Punjab. Actually, in few parts of Punjab, there have been traces of uranium in Punjab. So they are using reverse osmosis plants there in Punjab for getting rid of this uranium from drinking water.
Right, and thanks very much, Bashant. I apologise about the surname. I can't. It's too long. But you appreciate your time and coming into the webinar. Sebastian, what precision should one take before? What precision should one take before taking water for drinking when they don't know whether it contains fluoride or other harmful substance? in areas like Rajasthan? What precautions should one take?
Actually, what we have done in Rajasthan, that the hand pump which contains fluoride, we painted by red color. It cannot be, you cannot take this just water in the glass and can tell just by looking at that
Right.
water that it contains fluoride or something. So you have to first of all ensure that the source from which you are drinking water, it is contamination free. So for villages, what we are doing there, we have painting the hand pumps from which they are taking water with red color, so that they can identify that this particular source, it contains contamination. So important thing is that you have to ensure that the source from which you are taking water is free from any contamination. Just by looking at water, you cannot tell.
No, you can't tell. So arsenic is a classic case in point. No odor, no taste in arsenic. Perfect.
Neither in arsenic, nor in fluoride, nor in nitrate. You won't feel any taste.
Right. Well, look,
only salinity can be felt.
Only salinity, yeah, that's true, yeah. Is it? There's one more here from Botswana, and then I think we might leave it at that point. Is algae a challenge in water treatment?
Yes, it is. In our Rajasthan, in many cities, we are now facing problem. The surface source, which is a distant water sources, that Rajasthan Canal, Indira Gandhi Canal, that water travels to a long distance, and in between the fertilizers which are being used in farming, they get trapped in the canal water, and that becomes a source for algae development. And at many of the other water treatment plants, during the season changes or this turnover of reservoirs, we face this problem. And for that, some modern techniques are being used. And here at Adelaide, this Dept system is also used. Ultraviolet treatment is also being used. These definitely help in algae control. They are having reservoir management also to control the algae. They are dosing copper sulfate in the reservoir itself to control the algae.
I think we might leave the questions there now. It's been an absolutely brilliant 45 minutes of the question and answer and discussion. And I want to thank everybody who's joined this webinar. It's been really good to see so many from so many different countries, and also particularly to the participants, the speakers and presenters, 7 fellows in this water management fellowship between South Australia and Rajasthan. We've been delighted with your time today, and thank you for making yourself so available, especially on your birthday, Dr. Dinesh. We won't sing in the webinar. We might censored if we start singing, but in the webinar. But we are so delighted you could join us, everybody. So that's it for today, and we look forward to you joining us at a future webinar by iSwarm. We're up to about 20 or 30 webinars now. You can see them on the iSwarm website, and we'll be jumping right into webinar per week or per fortnight on Thursdays in 2018. So thanks for joining us, everybody. You can see the Twitter handle at the bottom there, at iSwarm, to keep up with everything that we're doing. So glad you could join us. Thanks for participating. See you next time. Bye for now.
Thank you.
Thank you.
Thank you. Bye.